Cool. My name is Leena Joshi. I run product marketing at Redis Labs, and today's talk will be about Redis Enterprise. Joining me on stage will be Guy Lubovich, who's a senior solutions architect with Redis Labs, and Uri Sacher, who runs the cluster group at Redis Labs. And you'll be seeing, as part of this presentation, you'll be seeing some slides and a couple of demos. If you like the demo this morning done by Kelsey, then I suggest you stay for both the demos. All right, so a little bit about the name of the product. When we talk about enterprise, and this is Nerd Girl here, I think about Star Trek. Anyone a Trekkie here? Awesome, cool. We think it's going to be so cool when we come deal with an enterprise product. We're going to be going where no man has gone before. But in reality, when you're working with an enterprise product, what you want is simplicity. You want, are people using Redis here? Everybody's using Redis? Awesome. So you want to retain the simplicity, the versatility. You don't want a lot of headaches. You want it to be easy. But when it comes to security and availability and all the things your boss could call you about at 3 a.m. in the morning, you want the seriousness of these people who are out to get the aliens. Right? You want them to anticipate. You want the product to anticipate already any potential availability situations you could run into, any potential security situations you could run into, and you want all of this built into the product. So this is what we endeavor to do with Redis Enterprise. Redis, of course, you all know and love it. It's an open source product. Redis Labs is both the open source home as well as the commercial provider of Redis Enterprise, which is the technology that powers all of our products. And these products are wherever you are. So anyone already using Redis Cloud here? Anyone running in the cloud here? Yes? OK, just a few. All right, so Redis Cloud actually has something like 65,000 customers. It's available in all of the major cloud, major infrastructure as a service clouds, as well as in Heroku. Redis Cloud Private is available inside VPCs, so inside private environments of major public clouds. Self-service for Redis Cloud Private just went live today, so you can even sign up for Redis Cloud Private and get the full benefits of Redis Enterprise in your private cloud environments. Redis Pack is downloadable software, which you can run on premises or in an environment of your choice. And Redis Pack manages a fully managed service that comes with Redis Pack if you need it. So the common things amongst all of these products is that it is powered by the same Redis Enterprise technology. A little bit about our origins. We started as a Redis service provider sometime in 2011, and we built the high availability and the automated scaling that our customers have been requesting. And this technology, Redis Enterprise, we made available as downloadable software. So that's what you see as Redis Pack. Make sense? All right, so over the years, we have managed over 250,000 databases, Redis databases worldwide. Today, we have 65,000 customers, of which 7,100 are enterprise customers. And on the downloadable software, which has been available for a year and a half, but is already run by very, very large companies like Groupon, Visa, et cetera, we have about 200 plus enterprise customers there. And that's our customer wall. As you can see, we have customers across the board, across all the verticals, all the major names that you can think of. And just going back to what does running 250,000 databases teach us? On our platform, we enable creation of 600 new databases every day. Your databases are provisioned within seconds. And over the years, we have withstood about 2,000 plus cloud node failure events and outages without any data loss for the customers who've chosen our high availability options. So this is just to show that we have the robustness and availability that you would expect from an enterprise product. Today's talk, I'll cover sort of the enhancements that you can expect in Redis Enterprise. If you're already using open source Redis, then you can see that Redis Enterprise makes it easy to scale, makes it very highly available, adds a lot of security, adds the ability to run with flash memory as a RAM extender. We'll talk about extensions like modules and the benefits you get out of manageability with Redis Enterprise. Before we get into any of these topics, I'm going to talk a little bit about what makes this possible. How is it possible that we are doing all of these things without impacting performance, without limiting you on what commands you can run with Redis? It's really that we have taken open source Redis and encapsulated it in a container-like structure where we've added a zero latency proxy, a cluster manager, and a REST API. The REST API is for management. Now, the addition of these components makes it so that it is really, really easy for your applications to scale when you're using Redis. The proxy also includes optimizations that actually stabilize and enhance the performance of Redis for you. And we have customer feedback saying that this is one of the big reasons why they choose Redis Enterprise. And lastly, the cluster manager allows us to implement a scaled out architecture where we're constantly monitoring the nodes, making sure that the throughput and latency is meeting your goals. And we're constantly rebalancing shards between the nodes, making sure we detect failure events and triggering the automatic failover within seconds so that you don't experience data loss. Make sense so far? This is also the reason why we support 100% of the open source Redis commands. So if you're using pipelining commands as an example to save on network round trip times, then this will work with Redis Enterprise. Today, if you run Redis in clustered mode, you're typically not able to use those commands. Make sense? All right. So the addition of the clustering technology, the Redis Enterprise cluster architecture, helps us to segregate cluster management activities from the data path, which means that you see stable, optimal performance for Redis, while the cluster management activities are going on in the background without interfering with your application access of the data. Questions so far? All right. So first, we'll talk about scaling, what this means for you in terms of scaling. What this means is when your applications are accessing Redis, they have a single endpoint to interact with. That single endpoint is the Redis Enterprise. And we scale out by adding additional Redis instances on the same server or on multiple servers as part of your cluster. So in a shared pool of memory, we create additional instances. Now, what's the big benefit of this? One is your application endpoint does not need to change. You can still interact with Redis as if it's a single instance. All the sharding, the scaling is transparent to the user. Make sense? The second thing is Redis is single-threaded. So if you're running it on a very large instance that has a lot of CPUs, it's only really using one core. So with the addition of being able to add additional Redis instances, you're also using your servers that much better because each Redis instance then uses an additional physical or virtual core that may be on your box. Make sense? So we're getting better hardware utilization. We're making it so that the application endpoint does not need to change. You do not need to change your application in any way when you're interacting with Redis Enterprise. In fact, if you're running open source Redis, to switch to Redis Enterprise is a single line command. You literally have to do nothing. Next, we talk about high availability. The thing to remember about high availability is that it is extremely easy to provision with the product, whether you're using Redis Pack or Redis Cloud. So I know the screens are not very clear here, so I'll just walk through what you would be seeing. In Redis Pack is just point and check for, I need replication, I need data persistence, I need an append-only file per write, I need an append-only file, I need AOF, fsync every write, AOF, fsync every second. You can also choose options in here that talk about how many replicas you need. On Redis Cloud, you can simply choose a plan that incorporates all of the availability options, and we take care of all of that behind the scenes for you. So instead of me walking through the UI, Guy will show you a demo of this in a second. But the key point to take away is this. When you think about all the failure scenarios for Redis, you could have a process failure, a node failure, a multi-node failure, a network split, zone rack failure, region or cloud failure. You basically are covered for each one of those different types of failure with Redis Enterprise. So we have in-memory replication, which is diskless, so it's faster and you're closer to your original. We have multi-data center, multi-zone replication, instant automatic failover, AOF data persistence, backup and snapshotting, and multi-region, multi-cloud replication. We did a benchmark on this. And the benchmark last year, I think it was last year, we compared Redis being provided by other vendors, and we've sort of scrambled the names here, with Redis being provided through Redis Enterprise. We simulated failure scenarios. We can tell you how you did that. You send us an email. And we noted the average time to recover in seconds, as well as how many times data was lost. And you can see that in every scenario, all the other vendors took many, many minutes to recover and lost data many of the times. Whereas Redis Enterprise recovered within seconds, less than 5 seconds, and did not lose the data. All right, so now we move to a demo. Oh, yes, sorry, before we get there, just a little bit of a reveal. People going to be here tomorrow? Yes? Wonderful. So watch out for this demo in the keynote. It is very, very cool. There's also a deep dive session at 3:15 tomorrow on this. All right, so with that, I'll move over to Guy's demo.
Thank you. So we're actually going to see it live. We're going to see Redis Enterprise live. I have right now a setup running on one of the clouds. I have 3 nodes. I have a cluster. It's running and working. And what I'm going to do is I'm going to create a database and show you how I can scale it very easily and make it highly available as well. So I'm just going to create a new database. As you can see, this process is very, very simple. I have a UI. I can also do it with REST API. Just Redis DB. I'm going to allocate 20 gig. I can actually create a database that will use the entire memory of the 3 node if I want to. And just click on activate, and that's it. Database has been created, provisioned on one of the nodes. I already have an endpoint, which uses a proxy. So we use a proxy to connect from the client into the Redis itself. This is the host name, and this is the port. The discovery is actually done through DNS. And what I'm going to do at this point is I'm going to run a benchmark that will load this database just a little bit. So I'm just going to take the ports. I already have. I'm going to connect to another node within my cloud. Yeah, just a second. And I'm just running a very basic memtier benchmark command. Just do a sets and gets of a few keys. I can go back to the UI, and I can look at the metrics. So this benchmark is doing 500,000 operations per second on a single Redis process, just a single Redis process, which is, as you know, single-threaded. What we do is we actually have the proxy, which is multi-threaded, that allow us to enable the multi-connection and actually generate more traffic than what we could have done just directly communicating with Redis. So even though I have the proxy, the total performance is higher. The latency here is 0.5 millisecond, which is the proxy latency. It's not the client latency, but I can actually measure how much time it takes me from the moment I send the command to the proxy, to the Redis, and back to the proxy and the clients. And I can see other statistical information here as well. I'm doing 400,000 reads per second and 100,000 writes per second. You can see the keys and all the connections that I'm doing. Now, the first thing I want to do is I want to scale my database, because at the end of the day, Redis is single-threaded, and I want to use the multi-core that I have on the host. So all I have to do is just click on clustering. Go into configuration, and it's very important because while my benchmark is running, I'm going to edit the database. I'm going to add a bit of capacity. Let's add 10 gig more. And I'm just going to click on clustering. What it does is that it actually switches from a single Redis master into 2 masters. So before I do that, I'm going to very quickly show you our CLI. I'm just going into one of the nodes, node number 1, and I'm going to open our Redis Labs admin CLI. Do a status, and I can see the nodes. I can see the single database, single process I have. I can see that all the traffic is going into that single Redis. Now, once I update this database, what will happen is instead of all the traffic going to a single master, the proxy will actually stop the traffic for a very, very, very quick time, like microseconds, and then start the traffic again to both masters. So it's already done. Now I have 2 masters, not just 1. Everything happened while my benchmark was still running, so my application didn't even know that something was wrong, and my throughput is up, my latency is down, and the main reason is just, even though I didn't change the load on Memtier benchmark, on the benchmarking tool, now I have 2 Redises that works for me. So I have 2 cores, I have more capability to do that. So throughput went up to 600,000, latency went almost by half. So it's half a millisecond, or sorry, 1.28 millisecond right now. Now, performance is not just important, you need it to be highly available. Also very simple. All I have to do is just go to configuration, just edit this database, and just with one click, I just need to click on replication, that's it. It doesn't matter how many masters I have, how big is my database, a slave will be created, and each master will replicate to that slave. So I will become highly available. I can do it node-aware, or I can do it zone-aware, or rack-aware if I want to. And Redis Enterprise will create a slave on a different node, rack, or zone. So I clicked update. Now I have masters and slaves, and now my database is just highly available. I didn't change anything on the client side. I didn't have to change it to a different client or add a specific code to support it. The throughput is not really going to change. And now I have 2 masters and 2 slaves. So all the traffic still go to those 2 masters through the proxy, but it's also being replicated to the 2 slaves. Now, let's take one of the masters and see what happened to the client. Just a second. I'm just going to kill one of the Redis masters. Yeah.
You're going to kill
Yeah, I'm just killing one of the processes. Sorry, just a second. Okay, now you can see this? Perfect. So what I'm doing is I'm looking for the process ID of this master, for example. Thank you. Thanks. And I'm just going to kill the process. So I basically killed one of the Redises while the client was running. I'm not going to change anything on the client. What's actually going to happen is that the proxy will fail over the master to the slave, and the client will automatically continue to work with the same endpoint. So It's already working. There's no problem. Of course, while Redis was down for like a split of a second or two, I had the connection drop. The cluster is already running. That was the drop, more or less, when I actually killed forcefully one of the processes, and everything is working fine. If I want to rebalance the cluster, all I have to do is just go into the admin and just run a very, very basic command. In this case, failover. So all I have to do is just failover back one of the Redis process, in this case 149, and again, without any effect to the client, this time no effect because I controlled it, the traffic goes back to the previous node in a previous setup, and everything is back the way it was before. That's it. Any questions? Yeah.
How does Redis database version upgrade works?
Version upgrade?
Upgrade the version for Redis database?
Yeah.
How does it work with Redis Labs?
So it's actually very similar to what you're seeing right now, which means it's just a single command. We take care of everything. The command is db upgrade. If I want to upgrade Redis binaries, all I have to do is just install something, no downtime, and then just do upgrade command, upgrade database, decide which database I want to upgrade. What it will do is it will upgrade the slave binaries, fail over the traffic to the slave, they will become the master, upgrade the master, fail over back, and all of that with that single command. So yeah, from your perspective, you don't care. It's still a single hostname and port.
Did you have a question?
Yeah.
So I attended a previous session where they spoke about elastic cache improving the robustness of Redis.
Yeah.
Where they were talking about they support increased number of master failures seamlessly. So I'm just trying to compare how do I compare Redis Enterprise versus that which is offered by Elastic Cache? Because it seems like both of them are offering similar things, and
it's a very, very long answer, but the most basic stuff is that I can run as many Redis processes on a single node as I want to.
okay.
So I can really utilize the processes. As you can see, I can scale and add more Redis as much as I want to.
Is some data loss possible on the failover? And if it is, how do I know that it happened?
Yeah, so if you use Redis, the replication on the enterprise version and the open source version is more or less the same. So losing data is possible with the enterprise. Redis has a consistency command called wait, which you can use if you don't want to lose data. And that works very well with the enterprise version. Anything else? Okay, thank you.
Thank you, Guy. All right, so we saw the demo for the high availability, the scaling. Everybody saw the Kelsey demo this morning? Yes? Only a few. All right, so what was demoed this morning was Redis Enterprise Flash running on Kubernetes. And why is this a big deal? Why are we talking about it so much? So in Kelsey's intro, he said, well, Redis is so good, I use it to store things, and then I use it to store more things, and then I really want to store many, many more things, and that could get expensive. And this is where Redis Flash comes in. Redis Flash allows you to use your SSDs as an extension of your memory. Now, SSDs are 10 times cheaper than memory, but they're slower. So, so does this mean that you compromise on Redis performance when you do this? So the thing to remember is the way we've implemented Redis Enterprise Flash, there is an additional layer of tiering that we've implemented. With this, keys and hot values are always stored in RAM, and the cold values are stored in Flash, which means that you can still get sub-millisecond latencies of RAM, even with a combination of RAM and Flash. Make sense? So this is why it makes sense when you have a very large data set in Redis to run Redis on a combination of RAM as well as flash memory. Basically, it saves you a lot of money, doesn't compromise on throughput, so it's a good deal. Where is it available? It's available on standard SATA-based SSDs, NVMe-based SSDs, and also on forthcoming new memory technology, which we'll talk about tomorrow in the keynote once again, and you'll see that makes a huge difference to the performance of Redis on Flash. A word about the cost. So how should you think about the cost? Like, is this a small cost? Is this a big cost? And one of our customers actually has a good way to think about it, which is that the amount of money that they would save on infrastructure was just totally worth paying the price of Redis Enterprise for. Not even including the management, the automation, the high availability, et cetera, et cetera. So this is just a bare bones comparison of what does it mean in terms of infrastructure costs. If you're using Redis on the regular open source Redis on RAM or running it on Elastic Cache with AWS, you would have to maintain 2 copies of the data to handle network split issues. You would probably use an AWS instance, which is like 1.32 extra large, and you would use 21 of those instances. In the case of Redis on Flash, because you're using Redis Enterprise, you actually need to maintain only 1 copy of the data because we do the network split handling at the node level versus the data copy level. You would use an i2 or an i3 instance, and the savings, as you can see, is very, very substantial in this case. Make sense? Over 80% savings. All right, so that was Redis on Flash. A word about security. Now, obviously, Redis is not a consumer-facing application, so when you think about how people implement security, defense in depth is typically the principle people follow. You would have Redis running inside a secure data center with top-level switches and firewalls for the first level of security. Then you have your perimeter network, and then you have the internal network on which Redis Enterprise Cluster nodes run. Now, when we're doing development of Redis Enterprise Cluster, we make sure to run automated security scans during the software development lifecycle and implement regular penetration testing so that we're not introducing additional security issues. Within the product, we provide security at multiple levels. When the application is communicating with Redis Enterprise, it is typically, you can choose encrypted communication as well as certificate and password-based authentication. When administrators are communicating with Redis Enterprise, we have encrypted communication as well as both password-based authentication and role-based authorization. And when we're doing the replication, cross-cluster replication, we have encrypted communication. So you have multiple levels of security within the enterprise product, which at the end of the day also simplifies compliance. The 4 pillars of compliance shown here are authentication, authorization, auditing, and encryption. And you can see that the Redis Enterprise products support sort of all 4 levels. Make sense? All right, next we talk about extensibility. With modules, you can really extend Redis to any data processing scenario. And over the last year, we have seen over 50 modules emerge from both Redis Labs as well as the community. There are sessions throughout the day today as well as tomorrow that talk about some of the modules that have gained the most amount of interest. If you were looking for a recommendation from me, I would definitely catch the Redis search module and JSON module session that's on right after this one. And tomorrow, there's also a session on machine learning with Redis ML. And there's a session on the graph module. Basically, the sessions will show you that instead of maintaining specialty databases that do one thing, it's probably better to implement the functionality as a module, use Redis to run it. While you may not get all the features of the specialty product, you would probably get good enough features at great performance. Make sense? So modules will be shortly supported within Redis Enterprise. Another aspect of Redis Enterprise is actually that it's integrated with every environment that you could think of. We run Redis Enterprise on every infrastructure as a service cloud, every region, every zone. Platform as a service clouds, both public and private clouds. So you can see Heroku, Pivotal, and OpenShift there. And we're integrated with the microservices orchestration tools if you run microservices yourselves, such as Kubernetes, which you saw this morning, Swarm, and Mesosphere. All right. So one thing about the manageability is that with our experience of running Redis over thousands of instances for our customer, what we have incorporated into the product is the maximum possible utilization of infrastructure that you can possibly do in Redis Enterprise. So some of the efficiencies that we've built into the product. So whether you're running a virtual environment or a microservices environment, you're always at the risk that your infrastructure is not being utilized and you have less control over it because of the additional layers of abstraction that you've imposed on your infrastructure. What we're doing here is we're making sure that out of your infrastructure, you can gain the maximum possible number of Redis instances that you can run. So we've incorporated shard isolation and protection. The various instances of Redis are isolated from each other. They do not interfere with each other's operation. If we notice noisy neighbors, a particular instance taking up too much of your CPU or memory or causing throughput issues, we do automated load balancing to migrate it off to another server so that it doesn't impact the other instances. And we also minimize the CPU consumption allocated to inactive instances. And because of this, we can squeeze up to 200 Redis instances on a single four virtual core server. And with that, we approach our next demo. So one of the benefits, Redis, by the way, is one of the most popular databases that is run inside a container. And recently, we launched a preview of Redis Pack inside the container, inside containers. And of course, this was in response to our customers who are running containers, and they want continuity between their production environments and their dev test environments. But also, it comes with the added benefit that you can use Redis Enterprise Flash technology, so save some money in your dev test environment as well. And you get the higher availability, the easier to scale, simpler to manage Redis Enterprise. And you're maximizing resource utilization. So this brings us to our next demo. And the next demo is really running Redis Pack in a container and orchestrating it with Docker Swarm. Compose, yeah? All right. So Uri is going to run the demo.
So hi, I'm Uri, and I'm going to use the next 10 minutes to quickly go over running all that enterprise goodness on containers and show Redis Pack running on Docker, Docker Compose, Kubernetes, and also discuss a couple of the trade-offs and challenges with running stateful applications inside containers. Okay, so first off, Docker and Docker Compose. And this is a live demo, so I hope the demo gods are with me. Simply to run it on Docker, simply do Docker run. You can see that the container is spinning up, putting up all the services. And we can now log into the local UI. Quickly ignore the security warning and set up our brand new node. Com. Com 1, 2, 3, 2, 3. And now the node will quickly set up all the cluster infrastructure. Note that this is a node inside a container approach. So we can create multiple databases on this single container. A, B, C. And let's set up another one, B, C, D. OK? So we have a container running 2 different Redis databases, and that's pretty simple to set up. However, if you want to test a real cluster environment, you need to set up multiple nodes. You want to test failover, things like that, high availability. You want more than a single Redis pack node. Easiest way to do that is to use Docker Compose. It allows you to really quickly set up a fully working cluster and use it, play with it as a test bed, look at the API, look at the UI, and work with everything. So this Docker Compose script will start up 2 Redis pack nodes and a client based on memtier benchmark. Let's log in. It takes a bit of time to spin up the cluster. And now it will bootstrap it automatically. Here we go. Okay, so as you can see, there's already 2 nodes spun up and no databases. So let's spin up a couple more nodes. Sorry. Okay, so I'm spinning up 2 more nodes. And we can also scale up the number of Redis clients. Equal 3. And finally, let's create a database via the API. I've spun up a lot of clients now, so it will take a bit of time. Here we go. So that's the API response, and you can see, by the way, that it's running on a version 4 database. Let's go into the UI. We can see that the database is up, and it will soon start receiving traffic. Here, it jitters quite a lot since everything is running on my single laptop. The fan is now spun up, and people that are close by can probably hear it. Let's look at the nodes, and here you go, 4 different nodes, everything tied up together without having to do anything. So that's nice. Again, it's very comfortable and convenient for working locally, for evaluating the technology, but it's not something you want to bring up to production. So let's tear this down. And really, really quickly show Kubernetes, even though Kelsey really set an impossible high standard to follow. So I've already spun up the Kubernetes cluster. We can show the pods. It runs, and you can see that there's 3 different pods. I can scale the number of pods to 5 very easily. I can start up clients, and it works very well and sets everything up well. And, well, if you missed Kelsey's lecture, I strongly suggest viewing it on video. It was really, really good. That's pretty much it in terms of the demo. A couple of words regarding the trade-offs when running a clustered and orchestrated service inside another clustered and orchestrated service. First thing that I'd like to mention is service discovery. If your apps are running inside the orchestration framework, things are very easy. You can use internal DNS, Sentinel, app-level DNS configuration, a lot of options for your apps to discover the Redis databases. If your apps are running on the outside, if the clients are outside of the orchestration framework, you really need to do some sort of, in the Kubernetes language, it's a controller that basically exposes a service based on what you configure your Redis Labs enterprise product to expose. And that's one of the things that we're working on when making the product GA on Kubernetes. The other technical trade-off is around upgrade. The in-place upgrade approach does not work in the container world. There's 2 main options. You can snapshot to a persistent volume and start off a new container from it. It's time consuming. It's not exactly seamless. There's quite a long period of outage, talking a couple of seconds. The other option, start up a new container and do an orderly migration. It requires slightly more RAM in terms of hardware capacity, but it's completely seamless as far as your clients are concerned. Spin up the new instance, migrate the databases to it, and slowly drain all the old connections whilst starting new connections with the new node. That's about it. In terms of supported platforms, Redis Pack runs on, in beta mode, Docker, as you saw, Docker Compose, Kubernetes, Mesosphere, and we're working on Docker Swarm now. That's it for me. Any questions? Yes.
In container, it's tend to fail, right? Where is the state of the cluster manager? What do you call it? Yeah, where does it store this information, the metadata information about the cluster, who's master, who's slave, and how is it stored in container world? Like,
okay. So as I mentioned, the question was, where is all the cluster state stored? And we're essentially running an orchestration framework inside the other orchestration framework. So we have our own cluster manager running inside each and every one of our nodes, and they all talk together and decide on who the master is and how many databases there are, things like that. As part of the container, yes.
it will end up in a data loss? Or how do you recover the state if it's all within the container?
I'm not sure.
How do you manage? I mean, you have to specify who's master, who's slave.
No, the failover is handled automatically. If a node fails or if multiple nodes fail, the other nodes, as long as there's a remainder of a quorum, you have to have a quorum remaining, they will decide automatically, negotiate and decide automatically who the new master is. You don't need to do anything. So, thank you very much.